In this harness test practice, we're going to compare two different materials. The steel 1018 that have 0.18% of carbon and the 1045 that have 0.45% of carbon. We're going to use three different types of tests and three different types of machines. The Vickers test, the Rockwell test, and the Brinell test. The best part of these three tests and the best part that we have the three different machines is that we can know that if our hypothesis was correct, that is that the steel 1045 is harder than the steel 10.
The first analysis we have to do is a Brinell hardness number for the 1045 steel. In theory, the strongest metals of the two. So after applying the force with the ball, we ended up with a shape almost like this in the 1045 steel, and we had to calculate somewhat the diameters. We did this 2 times, and we ended up with a shape like this. So we estimated the measured diameter. So we have 3.3 and 3.2. We got an average of that, and then we searched in the tables for the Brinell hardness number in kilogram force over square millimeter, and we got this average. Then we investigated in the American Steel and Iron Association for the 1045 number of Brinell hardness number, and we got 163. Well, we searched that, and we got a percentage of error, and we got 8.28, which is pretty close, given that it's lower than the 10% that is normally accepted. The test we performed was in the 1018 steel, which is in theory softer than the 1045, and we can see that in the diameter. It has a much bigger diameter than the last one, because the force causes a bigger indentation. So the first diameter that we measured was that we could make out was 3.7 and 3.75, which gave us this average. And then we searched each one in the tables and gave us an average of 133. And then we investigated the real result. That was 126 kilogram force over square millimeter. And we got an percentage of error of the 5.55%.
In the Rockwell test for the steel 1018, we get these values. In the first measure, we obtained 19.7 HRC. In the second, 19.5 HRC, and the average is 19.6. And when we investigated the results of the harness, we only obtained that we get 71 HRB, but we can't compare this one with this one because this is HRB and this is HRC. So we don't know about how far we are from the result from the practice or the official.
Okay, for the Rockwell test in the steel 1045, we got these results. The first test was 18.2, the second was 15.84, giving an average of 17.02 HRC, which by the way HR the identifier for the Rockwell machine, and C is the letter we were counting. The result gave us an error of 6.37, which is inside a range validation, so our test was a good one.
Then for the steel 1045, we get this measure that is all the units of hardness. It's in kilogram per square centimeter. Here we have 347, then 338. Then the average of that two is 342.5, and the real value is 370. Here, if we compare the steel 1045 and the steel 1018, we can see that we get more hardness here because the diameters of the indentation are smaller than the 18 steel. For the 1018 steel, we do the Vickers test. The Vickers test is a test in the one we do an indentation in the material with a diamond tip. Then with help of the microscope that we have in the machine, we do a frame of the indentation, and we calculate the distance that we have in the indentation. Then with help of a table of the Vickers hardness, we get these values. In the first measure, we have 203 kilograms per square centimeter. Then in the second measure, we have 240. The average of that two is 235. And then we investigate the hardness, the real hardness, that was 131. This is with reference to the American Iron and Steel.
My recommendation for efficiently performing a hardness test, first of all, is having the fill the machines or each machine with a good calibration. Also, the material has to be in good conditions. It needs to be clean and with no deformations. But also, each material, for example, the steel, comes with a certain pattern. For example, the steel we use, this has the pattern of 66.0 and 64.1. And well, the test we will that showed us the practice shows a specific number, and for example, in our case was 65.9. As you can see, this enters inside this range, and inside the range, it means that the test was efficient. But if this result comes out from this specific range, it means that the hardness test was wrong and it has to be repeated.
Why is it important a metallographic finish for a Vickers test? Well, that's because the Vickers test is done on a microscopic manner. So in the same manner, when you want to look your pieces on the microscope, it needs to be perfectly polished and ready, otherwise you wouldn't look it perfectly on the microscope. And you have to use it because you have to use the microscope to measure the diagonals of the diamond you're going to get on the Vickers test. So that's why a metallographic finish is important.
The second test done was the brilliance hardness test, where a metal plate was placed in the base, and then with air pressure, the durometer came down in this direction. This is our metallic plate, and this is the durometer. The difference is that this process is applied with pressure. Then, with a tool that is like a little tube with a light, we could see a little scale, where we could see this being we could see this one. This is the cavity, and this is a ruler, where you could see the specific measure for the cavity.
So I really enjoyed this practice because it was a different test for materials that I never did before. And Unfortunately we got the results we expected to be the steel 1045 with stronger or better results than steel 1018 because it has more carbon, therefore it should be a better alloy. I also enjoy to be working with different machines and with different units and process to work with the pieces.
I can conclude from this practice that all these kind of hardness tests, they are really useful for us to selecting the right material for our processes. In this case, if we're trying to manufacture something and we don't know if we want a kind and a specific material or another composite or another alloy, we can test all the hardness, this point hardness tests that will help us define which is the best option for us and for our purposes. In this case, we defined that the steel was much harder than the other material, and this will help us. It was an example that all the Vickers hardness machine was really accurate, but it still have a range of error because when you are moving the knob, it depends also in the interpretation of the person. But because it's a really microscopic measurement, it's irrelevant if there's a small change in size.
I can conclude from this hardness practice that we could successfully prove that the 1045 steel was much stronger because of the size of the indentations were smaller than the 1018 steel.
Making the procedure for this experiment, I can conclude that it was a really interesting experiment because it was the procedure so simple, but at the same time really important to know how the three machine works. And also we can conclude that the steel 1045 is more strong than the 1018 using the three machines.
The test of the hardness of the materials was a very interesting part for me because it is the fundamental part of the materials and how we can do some alloys and stuff like that. But in the part of the result of analysis in the practice was a very difficult part because the results that we obtained in the practice was very far from the results that we investigate about that material.